It was July 30th, 2026, and the city wore the heat like a guilty coat. Rain came down anyway, thin and nervous, tracing crooked lines across the precinct glass. The phones had been quiet all afternoon, which only meant the night was loading its gun. By sundown, 4 case files hit my desk. 1 break-in, 2 armed robberies, and 1 murder with fresh fingerprints still wet on the handle. No repeat offenders from the KEV board tonight, none caught in the act by the federal beat cops. But my informant, the EPSS ledger, still had a whisper for each one. 3% odds apiece that these perps come back swinging white 26, white 26, white 26. Not in this town. First on the slab was CVE-2026-13773, a medium break-in with a CVSS score of 62073, a medium break-in with a CVSS score of 620%. The address was IBM WebSphere Extreme Scale versions 826.26.26. The kind of enterprise middleware that lives deep in the basement, trusted by bigger machines upstairs, rarely seen until something starts bleeding. The technical wound sits in ogclient.jar, where roughly 50 generated Corba stub classes call orrb.string2object during Java deserialization. The likely category is CVE-502, deserialization of untrusted data, with a dangerous assist from attacker-controlled external reference handling. The attacker does not need magic. They need a path where an unfiltered object input stream in WebSphere application server accepts a serialized object containing one of these stub classes. Step 1. The attacker submits crafted serialized Java data to a vulnerable deserialization sink in a WebSphere environment. Step 2. The object input stream rebuilds the object and calls class logic inside the stub. Step 3. That stub reads an attacker-controlled IOR string. Step 4. orb.string2 object tries to resolve it. That can become server-side request forgery, network mapping, credential relay exposure, or a stepping stone to a deeper exploit chain. The scope is narrow in version number, but serious in placement. IBM WebSphere Extreme Scale 8.6x11.6 is the affected run. 0.6 is the affected run. WebSphere still has a long shadow in banks, insurers, government shops, airlines, and older Java estates where application grids and object caches keep business logic alive. An attacker gains a way to force outbound object resolution from the application environment, not necessarily direct code execution by itself, but in a real breach that may be enough. It can help reach internal-only middleware, trigger callbacks into monitored zones, or support lateral movement after an initial foothold. Exploitation depends on access to a deserialization path in WebSphere application server, or a related Java component that accepts untrusted serialized input. Authentication depends on that entry point, but the flaw becomes dangerous wherever untrusted serialization is permitted. The remediation is clean. Upgrade IBM WebSphere Extreme Scale to 8.6.17 or later, and make sure ogclient.jar is replaced everywhere it has been copied by hand. Sysadmins and middleware teams should inventory every WebSphere node, every shared library folder, and every application bundle carrying that jar. Developers should remove Java native serialization from exposed paths or apply a strict object input filter allow list. Network teams should restrict outbound Corba and IIOP traffic from application servers to only approved destinations. For detection, look for unexpected outbound IOP, Corba, or high-port TCP connections from WebSphere hosts after inbound application requests. In Java logs, hunt for deserialization errors, unexpected or.omg, CORBA activity, and object stream exceptions tied to external client input. But that was not the only body on the slab tonight. Next came CVE-2026-49805, an armed robbery in Microsoft Windows Win32K. The victim listed in the file was Windows 10 version 1607, the old branch still walking the alleys under long-term servicing labels in factories, hospitals, and embedded fleets. The mechanism is improper access control in Win32K, the kernel mode subsystem behind window management and graphics operations. The likely category is CVE-284, improper access control. The attack chain starts after the attacker already has a local authorized foothold, maybe as a low-privilege user, maybe through stolen help desk credentials, maybe through malware that landed through phishing. Step 1. The attacker runs a crafted local program. Step 2, that program calls specific Win32K user or graphics kernel interfaces with malformed or strategically ordered input. Step 3, Win32K fails to enforce the right access boundary between a normal user context and privileged kernel behavior. Step 4, the attacker gains elevated local privilege, potentially reaching SYSTEM or an equivalent high-integrity context. The affected platform is Windows 10 1.1607, including deployments still covered under servicing channels such as Enterprise, LTSC, and specialized embedded use. That vintage still lives in industrial control rooms, medical stations, point-of-sale lanes, and legacy desktop pools, places where uptime beats modernization until the bill comes due. This is not a remote break-in by itself. It requires local access and authorization first. But that does not make it mild. In real intrusion work, local privilege escalation is the getaway car. Ransomware crews use it after initial access to disable security tools. Espionage operators use it to dump credentials. Bot herders use it to persist, hide, and move laterally. Remediation means applying the Microsoft security update that addresses CVE-2026-49805 for Windows 10 version 16 top hosts, dated July 2026 or later for the applicable servicing channel. If your build is outside support, the real patch is migration to a supported Windows release or a paid extended servicing arrangement. Sysadmins should prioritize endpoints where untrusted users can log in, jump boxes, kiosk devices, remote desktop hosts, and shared workstations. Security teams should monitor for suspicious child processes, spawn from user sessions that rapidly request debug privilege, load unusual kernel-adjacent components, or attempt credential dumping after a local binary runs. Look in Windows Event Log for new service creation, token privilege changes, Defender tamper events, and unusual process trees where Office apps, browsers, or script hosts lead to local reconnaissance. I barely had time to light another cigarette when the next file landed on my desk. CVSS93 EPSS probability 3.0%. The name on the toe tag was Kiota, an open API-based HTTP client code generator used by developers to turn API descriptions into client code. The kind of tool that sits inside build pipelines, developer laptops, and automation jobs. Quiet, trusted, dangerous when lied to. The technical mechanism is command injection by trusted presentation of untrusted specification data. The closest category is CVE-78, improper neutralization of special elements used in an OS command, though the flaw works through social and tooling trust rather than automatic execution in every case. Before Kiota 1.32.5, the command Kiota info read values from an open API document under XMS Kiota info.languagesinformation, information.languagesinformation bot long with dependency name and version fields. Step 1, an attacker publishes or submits a malicious open API description. Step 2, a developer or pipeline runs Kiota info against that description. Step 3, Kiota displays a spec-supplied dependency installation command as though it were Kiota's own recommended command. Step 4, the operator copies and runs it or automation consumes it, leading to arbitrary command execution in the developer or build environment. If the command includes curl to shell, package manager hooks, token theft, or credential exfiltration, the compromise can begin before any generated client code is reviewed. The affected range is Kiota prior to 1.32.5. Kiota is widely used around Microsoft Graph and OpenAPI client generation workflows, and it appears in developer stations, CI jobs, SDK generation tasks, and internal platform teams that produce client libraries for many languages. An attacker gains whatever the executing user or pipeline can reach. On a laptop, that may mean SSH keys, cloud tokens, source code, and browser credential stores. In CI, it may mean signing keys, package publishing tokens, container registry access, and production deployment secret. Exploitation requires someone or something to run Kiota info against a malicious or compromised OpenAPI description. Then trust the displayed command. That is user interaction, but in supply chain crime, a polite prompt can be as sharp as a switchblade. The remediation is exact. Upgrade Kiota to 1.32.5 or later. Developers, DevOps teams, and platform engineering groups should update local tools, build images, GitHub Actions, Azure DevOps agents, and any container that includes Kiota. As a workaround, do not run dependency installation commands copied from OpenAPI metadata. Treat XMS Kiota info content as untrusted input. Pin dependencies in reviewed manifest files instead of installing from displayed suggestions. Detection starts in shell history, CI logs, and package manager logs. Look for Kiota info followed by unusual install commands: curl, ww, ep, bash, PowerShell, encoded PowerShell, npm lifecycle hooks, pip install from unknown URLs or outbound connections to unfamiliar domains. Also review recent OpenAPI spec changes for dependency install command fields that appeared without peer review. The night was far from over. The fourth file was CVE-2026-59805, another armed robbery on Windows 10 1607, CVSS 7.8, EPSS probability 320%. This one wore a different coat. Windows Wireless Wide Area Network Service, the part of town that handles cellular modem connectivity. Old laptops, rugged field devices, mobile workstations, and industrial endpoints know the neighborhood well. The technical flaw is deserialization of untrusted data in the Windows Wireless Wide Area Network Service. The likely category is CVE-502, deserialization of a. The attack chain starts locally with an authorized attacker on a vulnerable Windows 10 1607 device. Step 1. The attacker runs a crafted program or supplies malicious serialized data to an interface consumed by the WWAN service. Step 2. The service deserializes that data without proper validation of type, structure, or trust boundary. Step 3. Object reconstruction triggers unsafe behavior inside a service running with higher privilege. Step 4. The attacker elevates privilege locally, potentially gaining service level or SYST level control. The affected platform is Windows 10 version 6007. The exposed population is smaller than the whole Windows world, but the deployments can be high value. Think logistics fleets, emergency vehicles, remote medical carts, retail failover terminals, and field engineering laptops with cellular modems or WWAN service enabled. The attacker needs local authorized access. No user interaction is likely beyond the attacker running their tool. The impact is privilege escalation, which turns a beachhead into a command post. In a ransomware scenario, this can help kill endpoint protection. In espionage, it can help collect VPN material or cache domain secrets. In lateral movement, it can turn one field device into a stepping stone back into the corporate network. Remediation is to install the Microsoft Security Update for CVE 2026-59805 for Windows 10 version 1.1607 from the July 2026 release train or latter. If the device no longer receives updates, isolate it or upgrade it. Where WWAN is not needed, disable the Windows Wireless Wide Area Network Service through Policy or Service Control, and remove unused cellular modem hardware from the profile. Endpoint teams should act first on mobile and field devices. Security teams should hunt for service abuse, unexpected starts of WWAN-related processes, local privilege escalation tool patterns, and suspicious activity shortly after low-privilege logon. Watch event ID 7045 for new service creation, 4688 for strange process launch chains, and endpoint alerts involving token manipulation or credential access after WWAN service interaction. 4 cases, 1 rainy night. Different weapons, same motive. Trust was the door left unlocked. Java trusted serialized objects. Windows trusted local callers too much. Kiota trusted words inside a spec that might have been written by a crook with clean stationery. Patch IBM WebSphere Extreme Scale to 8.6.1.7 or later. Apply the July 2026 Microsoft updates to Windows 10 File 7 where you still run it, or retire the old iron. Upgrade Kiota to 1.325 or later, and teach every pipeline that an OpenAPI document is evidence, not gospel. This is Jack Cypher closing the file for tonight. Keep your logs warm, your outbound traffic on a short leash, and never trust a command just because it came wearing a nice suit.